Welcome everyone. I'm Jonathan, and I head up the product analytics teams that work with Delivery, which is kind of everything related to riders within Deliveroo, and restaurants, which is restaurants. And Jamie here, he's working with me, and he's gonna introduce what we're gonna talk about tonight.
Yep, so my name's Jamie, and I'm a data scientist on the rider payments team. So, what are we going to talk about? So first of all, Jonathan is going to take us through, who Deliveroo are, which hopefully everybody, or at least is familiar and hopefully even ordered with Deliveroo. But he's also going to go through kind of like the birth of Deliveroo and the amazing growth that we've experienced to get to where we are now. And then I'm going to talk about some details on a particular experiment design, which we use quite frequently here at Deliveroo, which deals with some of the challenges associated with small sample sizes and high variance, for example. And then Jonathan is going to go back through how do we encourage the business to let us run all of these experiments, and then also actually act on these experiments. How do we kind of gain their faith and get everybody on board to let us do our job?
Thanks, Jamie. So, show of hands, how many in here have ever ordered with Deliveroo? Quite a few people. You that haven't tried, you should really try it. It's really good, actually. So let me give you a brief background on the recent history of the delivery space. So you remember like a decade or two ago, you'd have to go down to your local pizzeria, you'd have to pick up a menu, and then you'd have to make a call at a later stage to get your pizza, and it was all like a hassle, and it was not very convenient, right? So that was kind of how delivery started. But it's changed a lot since then. After that came the online marketplaces. So restaurants would be able to put up their menu on a web page, and people would be able to order, they would be able to get more orders, and things were getting more convenient. But there was still nothing provided as a service to restaurants in terms of delivering that food. They will still have to take care of that themselves. Someone from the pizzeria or whatever restaurants they would have to do the delivery themselves. Our founder and CEO, Will, he had a few problems with this. So one was the restaurants that he saw on these marketplaces. He didn't recognize any of them. There were no well-known brands. They were just like random restaurants. He wasn't particularly interested in ordering from them. And a lot of the orders that he made, they took more than an hour to get from the point that he were ordering, and that's quite a long time. If you're hungry, you want your food directly, right? And also, it was hard to know when are you going to get the food. So it's you'd have to basically sit on hold, put your life on hold for a little while I'm waiting for my delivery, and that's not a really good experience either. You want to know approximately when you're going to get your food. So he took all of those thoughts, and then he started Deliveroo and kind of the third wave, as we call it, of delivery. So that was kind of, bringing in well-known brands that everyone loves and want to eat at and from, making sure that you can deliver that food in a quick manner, less than an hour, and way less than an hour. We have some orders that take as short as 6 minutes, and that's an amazing experience if you're lucky to have that. And you would have a prediction you would have a sense of when you would get the food. So it would be much easier for you to you can order your food and you know approximately when you're going to get it. So since then, this was 5 years ago when Will started the company, and we've grown immensely since then. We're now in 12 markets. We've had 6 investment rounds and raised quite a lot of money, and we're in more than 150 cities today. 200, yeah, very close to 200, I think. So, we've grown immensely since then. A lot of things has happened in Deliveroo. And at the core of the company is really data and data science. And we kind of have 3 different legs of our data science organization. Product analytics, which me and Jamie represent. So we're going to show you some examples of what we do within that space soon. Algorithms, which is an example of an algorithm would be Frank, our dispatcher model, which assigns a rider to an order. Anthony is going to talk about that in a little bit and give you an overview of what's going on in that space. And then we have BI, business intelligence, which is kind of developing our thinking and our structure around how we report metrics and how different metrics relate to each other. The reason that we have so much focus on data is that the whole organization is really hungry for data-driven decisions. Everyone wants to make a great decision, and we fundamentally believe that a data-driven decision is a really good decision. So when it comes to product analytics, that really means evidence-based product development. And what does that mean? It's just a string of fancy words. In practice, that means experiments. And what do I mean by experiments? How many here have worked or are working with A/B tests or experiments or testing in general? A lot of people? Quite a few, yeah. There's some that hasn't, and that's okay. I'm going to go through an example just to give you a sense of what the concept is about. So the purpose of experimentation is to measure an effect on behaviors on something new that is introduced in the experience of the user. So imagine that we have a population of users. We can pretend that it's the riders that Deliveroo are working with. When we do an experiment, we split this population, this group of riders, into two different groups. One, control and one variant in the simplest of examples. And for simplicity, let's imagine we have the same size of the groups, 50% in each. To begin with, they are having the same experience. They're having the same rider application. They're following the same delivery process. Everything is the same. And then at a given point in time, we introduce something new to the variant group. And then we let the experiment run for a given time, and we measure the specific metrics that we've decided beforehand for the variant group and for the control group. And then we compare the metrics for those two groups, and the difference between those are the effect of this new feature. And one thing that is challenging with this in general is that there's an element of randomness to this. So you can never be actually sure that what you're measuring is exactly true. And one way to kind of reduce this uncertainty that comes from the randomness is to have a big sample size. And in this case with riders, we have 35,000 riders all across the globe. So we're pretty well set. We're in a good position to run experiments here, even if we drill down to specific geographies.
But wait a second, Jonathan. Wait right there. Because, cute little gif. Because on our side of the business, which is the rider side, we often don't deal with, like, for example, rider level or order level metrics. And instead, we think about the network and network level effects. And so I can illustrate that with an example. If we think about this restaurant, which is nicely displayed as a little pentagon in the middle of the page, which at the moment, let's imagine that this circle around it depicts its delivery radius. So at the moment, the restaurant can deliver 10 minutes in any direction. Obviously, in reality, the rules that govern how far a restaurant can deliver are much more complicated, but for the purposes of illustration. This is great for customer one, because customer one can order from this restaurant and can probably expect the food in a relatively short duration. But perhaps for whatever reason, as Deliveroo, we think that maybe this restaurant should be able to deliver further. And so we let it deliver 12 minutes in total in any direction. That's potentially, a good thing, but it's actually not totally clear, as it might appear on the surface, as to is that net good or net bad. And that's because there are obviously lots of stakeholders involved in determining the outcome of this business. And we can examine a few of those now. So, starting with perhaps who is more clear-cut, perhaps the clear-cut winners in this are the restaurant, number one, because the restaurant is going to probably get more orders. They can address like a larger proportion of the population of Deliveroo users. And so that's probably net a good thing for those guys. It's probably also good for customer 2 because customer 2 couldn't previously order from this restaurant. So at least they have the option to now. So again, probably they're a reasonably clear winner. However, there are other groups where it's difficult to say, right? So for customer 1, maybe maybe it's fine. Maybe it's just kind of like business as usual for customer 1, but it's possible that if the riders are now busy delivering to customer 2, then now for customer 1, he or she is going to take longer to get their food. And so maybe that's not a great thing for customer 1. And then if we think about the rider, for example, on one hand, it's a good thing because the rider is probably going to get more orders because there's this greater catchment area. And if we bear in mind that a rider tends to be paid a drop fee per order, which is a flat fee, then that could be a good thing. But that kind of assumes that they have spare capacity. And so if they don't have spare capacity, and perhaps if instead of delivering to customer 1, they're now delivering to customer 2, they've now got to go further to earn the same money. So again, it's difficult to say whether that is going to be a good thing or a bad thing for a rider. And then there's Deliveroo. And for us, again, maybe it's a great thing. Like more orders is obviously a good thing for Deliveroo, but it's potentially to kind of like mitigate against the deterioration in customer service levels, which we kind of referenced in customer 1. Maybe we need to put more riders on the road, which obviously represents a cost to Deliveroo. So there are lots of things here which is not totally clear, and there's a clear case for experimentation when we make a change like this. And because all of these things are not really isolated to a specific rider or a specific order or a specific customer or a restaurant for that matter, we need to perform some kind of level of aggregation. And a usual aggregation level that we use here is to like a zone level. And here we have the zones across London, and zones are just kind of a Deliveroo-specific thing. But they're very useful in lots of cases when we're looking at rider level changes, because when a rider signs up to work with us, they can assign themselves to a specific zone, which means that changes within that zone, at least from a rider level perspective, can often be relatively isolated to the zone level. Sometimes we will aggregate to city, but often like a zone is a reasonable level of aggregation which we use. And because of this aggregation, what it tends to mean is that conventional A/B tests, as Jonathan was describing, often aren't suitable. And there are lots of reasons really, but two of the main reasons are, one, like the sample sizes tend to be small. So if we're making a change that affects London, for example, and we're looking at zones, we've got fewer than 100 zones across London. Obviously, London's a huge city. And so 100 data points is actually a really small sample size to be performing any kind of experiment, an A/B test on. And also, there tends to be high variance within the data points. So within each of these zones, in this case, the high variance makes it harder to detect what has happened as a result of the change that we've made, rather than just some randomness. So this is when we use one of the experiment designs which we use quite frequently at Deliveroo is called block design. And there's a nice little quote here which is, block what you can and randomize what you cannot. I actually don't know exactly who to attribute, it's quite a famous quote, but I don't know who to attribute the quote to. I read it in a fantastic textbook by George Box, but I think he was quoting it, so yeah, I don't know, I'm not sure, but whoever said it first, I can illustrate what they mean and kind of the idea behind block design. And to go into that, I'm going to first talk about like nuisance variables, because they're kind of an integral idea to what we mean about blocking something. And nuisance variables are kind of exactly what they sound like. So they're variables which may well be correlated with the metrics which we're trying to observe a change on, but they're actually of no interest to the experimenter. And I can illustrate with a couple of examples. One, to go back to like the zones which you saw for London, the significant difference between, for example, like a zone around here in central London, which is incredibly dense, lots of customers, lots of riders, lots of restaurants. What that means is that generally, for example, if we're looking at a metric like average order duration, which is how long on average from when a customer says, you know, I want my food to they actually receive the food, the average order duration will be quite low in an area like this. However, if we go to like a zone, you know, further out on the outskirts of London or anywhere really, it can often be the case that the average order durations are much higher. So there's lots of variance there in those data points. And that we also have experienced like significant seasonality throughout the year, but also throughout the week. So as you might imagine, weekends are way, 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 way more popular for us than weekdays. So these are all things which we want to block out because this isn't something that we want to control for these factors, essentially. So here we go, block design to the rescue. And I'm going to illustrate block design with an example. So if we go back to the example we were talking about before with a single restaurant delivering a little bit further, let's think instead if we're going to apply something more general and more difficult to think about, because possibly you could model something like a single restaurant. But let's say instead we were extending the delivery radius for all restaurants of a certain cuisine type in London. Let's say we hypothesize that because perhaps sushi travels better than other foods, maybe we should extend the radius for all Japanese restaurants across London and track certain things. So things we might be interested in is like, does that change the average conversion? Do more people buy from Deliveroo because they can see more Japanese restaurants? Do we experience an increase in refunds? So perhaps it actually doesn't travel better, and we're having to do many more refunds now because these delivery distances have increased. What about for riders? Like, are riders now having to, like, are they able to deliver fewer orders because they're having to go further? Maybe that's not a great thing for the riders. There are lots of things here which, particularly at this kind of scale, when we're talking about, you know, huge changes across a whole city or even more than that, it's basically impossible to think about without some need for experimentation. So now let's talk about actually like the technical details of how the block design process works and kind of like in summary, the logic behind it. First of all, if we think about all of our zones, let's say that, you know, there are 100 zones in London, then we'll randomly split them into group A, let's say group 1 and group 2. And from that will assign kind of the treatments, the sequence of treatments that are applied to them. So in this example here, we've got a 2-week experiment that sort of starts on a Monday and ends on a Sunday. And we can see that zone 3 and zone 2 are in group 1. And so what this means in the purpose of it here is that on the first day, so on the first day of the experiment, which is the Monday, they will experience the B effect, which in this example is to say that the Japanese restaurants will have a larger delivery radius than they would do usually. And then that will alternate each day. So on the Tuesday for these zones, it will go back to what they have now. So the normal size delivery radius. And then that will continue. So it's in like a BA effect. So the treatment is on, the treatment is off. And then kind of like the opposite is true for those in group 2, which, so that's going to go in like an AB sequence. And what we can see here is that for each, in this like 2-week design, for each zone, they all have a single day. So they all have like a Monday, a Tuesday, a Wednesday, a Thursday, a Friday. It alternates to kind of keep like data effects out as well. And then from there, like the process becomes kind of like simple in some ways, because we just take the mean effect of all of the B days, so when the treatment was applied for each zone, and the mean of all of the A days as well, so when it's in its kind of like control condition, and we subtract the A days from the B days to give an effect per zone, and then we simply perform a one-sample t-test on all of these effects and test for significance. And kind of like, hey presto, like this actually quite neatly controls for the intra-week seasonality, which we talked about before, because each zone has an observation at a single day for like a single day of week, and also the inter-zone factors as well, meaning that we can actually deal with sample sizes and get reasonable significance on certain metrics on sample sizes as low as even 50. Not going to run on like I did.
Thanks, Jamie. So Jamie has described a really good method for handling cases and situations where we have very few samples. It's important for us that when we're doing these experiments, these type of things, that the whole organization is on board, so that we can really go ahead and do them, and we can measure our changes in a good way. So to do that and to make sure that everyone is on board, we've kind of employed a specific process, somewhat rigorous, for how we're going through experiments. I'm going to go through it just quickly to give you a short overview of how we do that. So that kind of involves design as the first part. So the design really the purpose of the design phase is to decide three things. One is which experiment method are we going to use. So it could be an A/B test, it could be the block design that Jamie just described. Second is where are we going to run this experiment. And third, what metrics are we going to use? And that depends on what we believe that this change is going to impact. When we have that design, we usually run a simulation, usually a Monte Carlo simulation, and that's to understand how good our accuracy and sensitivity is going to be on the metrics that we've decided. And that also determines how long we're going to run the experiment for. Sometimes we will need to go back to the design phase and change something there in order to get good enough accuracy in a timely enough manner. Once we're happy with the simulation, we start running the experiment for the time that we've decided before, usually between 2 to 6 weeks, somewhere in between there. And once that's done, we analyze the experiment. So we look at we try to estimate the effect of the change. And then we take that analysis, turn it into insights and a recommendation to the teams that are involved in this. So to summarize, the goal for us here is to help guide business decisions. And the problem that we have, often when it comes to our delivery network, is that we have very small sample sizes. And we solve that by a clever experiment design. So just to finish up, I'd like to reiterate that at the core of Deliveroo is data science. And it's an important part of our organization right now, and it's going to be even more important in the future. So we're bringing in a lot of people. If you are as excited as me and Jamie about this, then you should definitely come up and talk to us. There are a lot of people here from Deliveroo today, so you should definitely talk to Shane, Mike over there, Hugo, Ella. So there's a lot of people that are really keen to talk to you. Kavya is over there. So feel free to grab us when we're having food and drinks together.